Good morning and welcome to video number 1 on parabolas. Now, you are familiar with parabolas. You learned about them in Algebra 2. We talked about them this year as well. And you know that parabolas are basically U-shaped quadratic functions. Now, what's interesting about a parabola and something that you don't know is that all parabolas contain what I like to call this magic point here. This point is called the focus. Okay, and this is the actual name of it. It's called a focus point. And it's something that you have not learned about yet. Okay, so what's so special about this focus point? Well, for one thing, the focus point lies directly on our friend, the axis of symmetry. And remember, the axis of symmetry is basically a line that cuts the parabola symmetrically in half. If I fold the parabola over this line of symmetry, the left side will match up with the right side exactly. Now, what's magical and special about this focus point is that it is equidistant from the parabola, and a new concept, a new line that you have also not learned about called the directrix. And you might be thinking, who comes up with these names, right? The directrix. And the directrix is actually a line that is equidistant from the parabola and the focus point. Okay, so just to give you an example, let's say I draw an arrow from the focus point to the parabola. Almost looks like a vector. The distance of that arrow is exactly the same distance from the parabola to the directrix. Now, I did not draw that to scale, but imagine this arrow and this arrow being the exact same distance, okay? So again, if I draw another arrow here, that arrow should be the same distance as this arrow, okay? Now, again, I did not draw this perfectly, but you kind of get the idea. You know I can't draw. Okay, so all of those arrows should be exactly the same distance. The technical definition of a parabola that I have in my notes is a parabola is the set of all points that are equidistant to point AB, called the focus, and a line called the directrix. Okay, now what's really cool is if you were to go outside on a very sunny, bright day and you had a parabolic shaped piece of tinfoil or a parabolic mirror or something that looked like a parabola. Every single parabola has this thing called a focus point. And what would happen is if the sun's rays hit the parabola, right? So let's pretend the cool thing about the parabola is that all of the rays would be reflected back to the focus point. So imagine a bunch of sunlight coming in. And the sunlight is bouncing off of the parabola. And what happens is it gets reflected right to the focal point. Now you can imagine how hot this focal point would get if the sun's rays come to it and go back to this point. So this point will get super, super hot as the sun's rays come down to the parabola and reflect off the focus point. In fact, the parabola's focus point gets so hot that in the summer you could cook an egg, you could fry an ant, you could probably pop popcorn by getting the sun's rays to accumulate at this point. So before we move on, I actually want to show you some really cool videos on Edpuzzle about the parabola's magic power and how people have harnessed the power of the sun and using parabolas to actually cook things. So it's actually pretty cool. If we were at school, we could probably do some kind of experiment outside. But before we go on, I want you guys to watch these videos. So coming up next are some Edpuzzle videos that I'd like you to watch, and they demonstrate the magical powers of the parabola's focus point and the ability of the sun's rays to hit the parabola and go through the focus point.